Welcome to the Green IC Research Group at the National University of Singapore. In this video, we are happy to share our new smart tag with batteryless operation thanks to the incredibly low power consumption below 1 microwatt. As very distinctive capability, it reuses the same two-tone incident wave for several purposes. First, RF harvesting. Second, extraction of Wi-Fi compliant clock. Third, 802.11ba wake-up receiver. Fourth, Wi-Fi 802.11b backscatter transmitter. And fifth, 3D localization via signal strength detection. We now welcome Raywan and Karim, who will show the demo.
Hello, this is Raywan. In this test strip, we demonstrate a batteryless tag with 3D localization with an accuracy in the centimeter scale, which can be used in many applications such as the smart tag for fulfillment centers and warehouses. The tag operates through various phases once it receives an incident electromagnetic wave. Firstly, the plug-in device is shared among many tags and is placed at a fixed position. It starts a tag localization cycle by emitting an incident wave, reaching the tag and powering it up to start harvesting. It is followed by clock extraction and on-the-fly supply tuning for PVT calibration to suppress the extra power consumption that will come with PVT variations. Secondly, the Wi-Fi router triggers the first two-tone generation in the plug-in device for slow clock extraction and FLL frequency locking to prepare for the reception of the wake-up packet. Thirdly, the router stops the two-tone from the same plug-in device and sends a standard 802.11ba packet to trigger the tag wake-up and identification to trigger the response of the specific tag being addressed. Fourthly, the router triggers the second two-tone generation phase in the same plug-in device for the recharge of the storage capacitor and clock extraction to prepare for the reception of the Wi-Fi packet. Lastly, the tag to PID distance is sensed by digitizing the harvest voltage and transmitted back through backscattering. Now Karim will talk about the above-mentioned 802.11ba wake-up receiver for tag identification, which is the first reaching the aggressively low sub-microwatt range.
The wake-up receiver employs switched capacitor FLL that locks the output frequency on the extracted 312.5 kHz incoming wave in phase 2. The FLL is based on a capacitive ratio and generates a 4 MHz output clock frequency. After the steady state is reached, the FLL is unlocked to maintain the same frequency without external support of an incoming tone, so that the packet can now be transmitted instead of the tone. The 4 MHz clock is used for the minimally analog front end and for the digital tag identification through a Manchester decoder and a digital correlator. The minimally analog front end employs only a differential envelope detector and a novel fully differential offset compensated inverter-based comparator. Thanks to the simplicity of the front-end architecture, the entire wake-up receiver shows a lowest peak power consumption of 420 nanowatts, which is more than 200x lower than the prior art in this 802.11ba standard. Once the preamble and the payload are received, the correct tag is woken up, and it starts communicating its digitized harvested voltage, which really means position, using a two-tones Wi-Fi passive backscattering. These operations are repeated for two other surrounding plugged-in devices for complete 3D localization along the three axes with spatial resolution between 2 and 20 cm.
This demonstrates for the first time a smart tag whose power is 0.9 microwatts and hence below the microwatt mark for the first time, while simultaneously supporting all functions from harvesting to standard compliant reception and transmission and 3D localization. Interestingly, this is the only batteryless and fully integrated demonstration of on-chip 3D localization and has at least 15 times better spatial accuracy than commercial devices such as AirTags and more than 20,000 times lower power. Simple, accurate, and extremely low power, no battery. Thank you for watching. Feel free to explore more in our Green IC website.